Hello and welcome. This is going to be our lecture video for the Unit 6 Moles and Formulas test review. Let's get started with number 1. Calculate the molar mass of AlF3, aluminum trifluoride. So when we add up a molar mass, we need to have a periodic table in front of us, and we just find the atomic masses. And then we multiply them first by their coefficient and then add them together. So there's only one aluminum here. So I'll just write down the molar mass of aluminum, which is 26.982 plus 3 times the molar mass of fluorine, 18.998. All right, you can plug this into your calculator in one line. It will do the order of operations for you. And we get 26.982 plus 3 times 18.998. 83.976. And now pretty much every number we ever give needs a unit. The unit for a molecular mass or molar mass is grams per mole. That's how much 1 mole would weigh. All right, with the nickel chloride here, dihydrate, to add this one up, you need to do 1 nickel. I'm not going to solve this one, but plus 2 chlorines, so 2 times chlorine, plus 2 times what a whole water molecule is. This means we have 2 water molecules, and you can add up the water molecule separate, or just remember water is very common. It's 18.015. All right, so now once you look at the atomic mass for nickel and chlorine, you'll be able to solve this one. What's the name for this type of compound? All I was looking for this type, not necessarily this specific one, but because it has that water at the end, this is a hydrate. All right, this next section does you some favors because it's already added up the molecular masses. And now we just have to use these molecular masses to do some conversions. Number 4 says we're starting with 250 grams of calcium chloride. So we look at the molecular mass. This is grams per mole or grams per 1 mole. But I have to put that in here so that the grams cancel out. So I'll put the 1 mole on top and the 110.98 grams in the bottom. Now, how do we evaluate this? Well, we always multiply across the top, multiply across the bottom, and divide. But since there's only really one number on top and one number on the bottom, we'll say we just divide this. 250 divided by 110.98, and we get 2.25. Grams canceled out, and our unit is moles, which is what we were trying to answer. Convert to moles, so 2.25 moles. Now we're going the other direction. 1.87 moles of magnesium oxide to grams. So I'll start with what the problem gives me, 1.87 moles. Always write your unit when you're doing this so that you can see it cancel. And now I can look up here, 40.3 grams per mole means that it's 40.3 grams over 1 mole. And I put it in here this way so that moles would cancel. Now I just multiply across the top and I divide by 1. That doesn't change anything. And I get 1.87 times 40.3 equals 75.361. 75.361. And the unit on that is grams, the only unit left over here. All right. Student weighs a piece of chalk. Calcium carbonate is that formula, CaCO3, at 5.9 grams. Then the student writes his name on the sidewalk and then weighs it again. Now it weighs 4.5 grams. So why did it shrink? Because that chalk is now on the pavement. How much chalk is on the pavement? We'll figure that out by subtracting. 5.9 minus 4.5 equals 1.4, and the unit there is grams. Now we have to convert this to moles of calcium carbonate. We're not told the molecular formula for calcium carbonate. So we have to add that up ourselves. So before we can start the problem, let's figure out the molar mass of calcium carbonate. Calcium is 40.078 plus a carbon is 12.011 plus 3 oxygens, so 3 times 15.999. Plug this in, and I got that calcium carbonate weighs 100.086 grams per mole. So now let's start with, we used 1.4 grams. Now, grams has to go to the bottom, so the 100.068 grams per 1 mole goes like that. And now we divide. So 1.4 divided by 100 just about is 0.014 moles. All right. So I have a large balloon that contains gas at STP, standard temperature and pressure. If I know there's 0.05 moles of gas in the balloon, what's the volume? So we need to know that at STP, 1 mole equals 22.4 liters. This will be in the vocab section of the test. If you forget that number, 22.4 liters. Now, if I'm starting with 0.55 moles, I can multiply by the fact that 1 mole, that goes to the bottom, so moles will cancel out, equals 22.4 liters. And we see our unit on top is liters. That'll become the unit once we multiply this. So 0.55 times 22.4 equals 12.32 liters of gas. Capital L for liters. On to question 8. So we are trying to synthesize manganese chloride. And we took this data during the experiment. Mass of the manganese metal and then mass of the manganese chloride salt. Let's go through these calculations quickly here. Moles of manganese, so we'll go 0.98 grams of manganese times its molar mass of 54.938 grams per 1 mole gives us that 0.98 divided by 54.938, 0.0178 moles of manganese were used, and they didn't go anywhere. They stay in the reaction. Mass of chlorine in the final sample. To get this, we subtract. This way we're removing the weight of that metal, and the only thing left would be the chlorine. Moles of chlorine. Take the mass of chlorine in grams and multiply it by its molar mass, which is 35.45, but put grams on the bottom, so we really end up dividing. 1.27 divided by 35.45 gives us 0.0358 moles. So this gives us the ratio of Mn to Cl of 0.0178 to, and I mean 2 as in the colon, like compared to 0.0358. Divide both sides by the smaller number, and we get a 1 to just about 2. So 1 to 2.01 ratio here, which we're going to round to a 1 to 2 ratio. Now, how do we turn that into the empirical formula? We just use those as coefficients. This becomes MnCl2. Glucose has a molecular formula of C6H12O6. What's the empirical formula? When turning a molecular formula into the empirical formula, you remove any common factor. So I'm going to divide by 6 from all of those coefficients and get just a CH2O. Molecular formula that would have the same empirical formula as benzene, C6H6. So it needs to be a molecular formula that also simplifies down to the empirical formula CH. Possible answers would be just simple CH. C2H2, C3H3. I think you see where I'm going with this. C4H4 and on and on. All of those would have the same empirical formula as benzene. All right, number 11 here says draw a picture of a hydrate becoming an anhydrous salt. This is what that picture could look like. We'll start with some sort of salt here. Let me make it a little bit bigger so I can write inside of it. So that's our salt. That could be anything as sodium chloride, nickel chloride, copper sulfate. And attached to our salt is a bunch of water molecules integrating themselves into the structure of the crystals. All right, but it's a somewhat loose connection. It's just what we call a hydrogen bond, which isn't very strong. It's not like an ionic bond or a covalent, which is our strongest. So if I take this molecule here and apply some heat, so let's draw a picture of what heat looks like from a Bunsen burner. All that water will leave, and I will just have an anhydrous, meaning without water, salt. On to number 12. Below is data from a hydrate lab. The hydrate used was nickel chloride dihydrate. And then we took the following data. We can see it all in our data table. What was the mass of the water removed from the hydrate? So we'll take the mass of the test tube plus the hydrate, 36.5, and then subtract the mass of the test tube and the anhydrous salt. The mass of the test tube will cancel out. The mass of the anhydrous salt will cancel out, and all that will be left is the mass of the water, which looks to be 0.6 grams. All right. Molar mass of water is 18.015 grams per mole. You can either add that up or just remember that number. Convert the mass of water from letter A above to moles of water. So we have 0.6 grams. We will multiply that by 1 mole over 18.015 grams to get that we had 0.0333 moles of H2O. What is the symbol for the anhydrous salt left over? So it's just the nickel chloride. All right, extra challenge. What is the amount of anhydrous salt remaining after the water was removed? So we'll just subtract the empty test tube from the empty test tube plus the salt to get that was 0.9 grams. Molar mass of the salt, we'd have to add up nickel chloride. So let me just find that. Nickel is 58.693 plus 2 chlorines is 35.45. 58.693 is 2 times 35.5 gives us a molar mass of 129.593 grams per mole. And then calculate the moles of anhydrous salt remaining. So we'll just divide these two numbers, 0.9 grams, and then 129.593 grams per 1 mole. Plug that into our calculators. And we get a very small number, 0.007, almost 694. And if we want to keep going with this, what we would do next is we would set up a ratio here of these two molar amounts, 0.007 to 0.0333. Divide both sides by 0.007. And 0.0333 divided by 0.007 gives us almost 5. So it's like a 1 to 4.7 ratio, 757. And then we would round that up to a 1 to 5 ratio. So that tells us that it's probably a pentahydrate. 5 is pentahydrate. So that's how you finish that problem. On the back is vocab. Study it. Expect this on the test. That's that for this lecture video. Have a good rest of your day.